Myself Sanjeev Kesar Tripathi. I am from the MKD Education. Today we will start new session of chapter 1, that is unit and measurement. Yesterday I have already explained to you how we will find the dimension. Today we will going to be discuss. So first I am going to explain you the homogeneity. So homogeneity means in any mathematical equation or in physics equations, the dimension of the LHS, that is left hand side, equal to RHS, that is right hand side. This is called principle of homogeneity of any physical quantity. Has a expression any physical quantity in terms of MLT. Already what I explained you in the last class is called dimension of that physical quantity. Now we will going to be apply these dimensions in different aspect, and outcome after the end of the class, student can know about how the principle of homogeneity is used or stated in the dimensional correctness of an equations to convert one unit to another unit, as well as to derive expressions in dimensions and by using the dimensions. Next we will switch over to principle of homogeneity of dimensions. That already I have explained to you. This homogeneity means dimension of LHS of any physical quantity or in a mathematical expression is equal to right hand side dimension. That is called principle of homogeneity. Next, use of dimension analysis. The dimensional analysis or dimensional method is used to convert a physical quantity from one system to another system of a unit. Number 2, check the correctness of a given equations. Number 3, establish a relation between different physical quantity in an equations. Now we will switch over to different examples, and so that you can able to understand. Suppose first I will going to be convert, that is gravitational constant G, whose CGS unit value is 6.67 into 10 to the power minus 8 in CGS systems. Now I am going to be convert this value in SI system by applying principle of homogeneity. First I am going to be derive the dimension of G. In the last class already I explained to you the force is equal to G M1 into M2 by R square. So F is the force which is a gravitational force, G is the universal gravitational constant, and M1 and M2 are the masses of two different objects, and R is the distance between them. This implies G is equal to F R square by M1 M2. Now we are going to be deriving this dimension of that quantity. Already you know the dimension of force, that is mass into acceleration, and the dimension is m to the power 1, L to the power 1, T to the power minus 2. That is the dimension of force. And R is the radius, therefore it is L square. Therefore this expression becomes m to the power 1, L to the power 1, T to the power minus 2. I am substituting the dimension of force. Then this is L square, that is the radius square, that is length square, and then m square. Then after simplification this expression, the dimension of gravitational constant becomes m to the power minus 1 and L to the power 3 and T to the power minus 2. This is the dimension of gravitational constant. And CGS system is unit is dyne centimeter square by gram square. Its unit in CGS systems. By applying this principle of homogeneity and using this dimension, now I am going to be convert its CGS value 6.67, 10 to the power minus 8 into SI systems. I am keeping this dimension so that I have used these dimensions to convert its value from CGS system to SI systems. Now I have applied the principle of homogeneity. Principle of homogeneity states that N1 into M1 to the power X, L1 to the power Y, and T1 to the power Z is equal to N2, M2 to the power X, L2 to the power Y, and T2 to the power Z. So This LHS side I have used for SI systems and RHS side I have used for CGS systems. Therefore, this is for SI, this part is for SI unit system, this part is CGS unit system, because the unit system, in both unit system the dimension is remains same. Therefore, N1, this implies N1 is equal to N2 M2 by M1 to the power X and L2 by L1 to the power Y. That's T2 by T1 to the power Z. Here X is equal to, according to dimension, here X is equal to -1 and Y is equal to 3 and Z is equal to -2. You will compare with these dimensions. Then I have used this dimension instead of X, Y and Z. Therefore, by putting the value of X, Y, Z in these expressions, N1 becomes N2 M2 by M1 to the power -1, L2 by L1 to the power 3, then T2 by T1 to the power -2. Therefore, N2 is in CGS system, then its value is, as it is given, that 6.67 into 10 to the power -8. Now the value of N2 becomes 6.67 and therefore by putting this value, that is equal to 6.67 into 10 to the power -8. Then by using these expressions of this power, that is M2, though it is the CGS part, this is in grams, that is in 1 gram by 1 kg to the power -1. That is L2 in CGS part, that is in centimeter, that is 1 cm by 1 meter to the power 3, and then 1 second by 1 second to the power -2. Now we are going to be use this value of these expressions to convert one systems to another systems, and its value is constant, as you know. So therefore 1 kg is 10 to the power 3 grams. Therefore N1 is equal to 6.67 into 10 to the power -8. Then this is 1 gram by 1 kg is equal to 10 to the power 3 grams. This is equal to 10 to the power 3 gram to the power -1. That is 1 meter is 100 centimeter. That is equal to 1 cm by 10 to the power 2 cm to the power 3. Then second and both are same, no need to convert. 1 second by 1 second to the power -2. Therefore this equal to 6.67 into 10 to the power -8. 10 to the power -8. Gram cancel, cm cancel, second cancel. Now 10 to the power 3 to the power -1, this becomes 10 to the power 3. And this is 10 to the power 2, this is in the denominator. If it is go to the numerator, then it is become 10 to the power -2 to the power 3. That is into 10 to the power -6. And simplifying this expression by using exponent rule, 6.67 into 10 to the power -8 plus 3 -6. Then it will be evaluated 6.67 into 10 to the power -8 -6, that is -14. -14 plus 3 is -11. Therefore its value is Newton meter square by kg square in SI systems. So already here is in CGS value of gravitational constant 6.67 10 to the power -8. In SI system its value is 6.67 10 to the power -11. This way you will convert from one system to another system. I am giving one task, you, my dear student, you have to convert from 1 joule to hour. This is my question to you. You solve in your home, and if you are unable to convert, then next class I am going to be explain you. Convert 1 joule to org convert that by this process. Next application, we will switch over to correctness of the equations. Next we will be change to our topic, then how we will check the correctness of a given equations. So my equation is equal to S is equal to ut plus half at square. This is the equation of motions. My dear student, S is equal to ut plus half at square. First I am going to be define the term. S is the distance travelled by an object, u is the initial velocity, t is the time, a is the acceleration, t is the time. Then to check the correctness of equation, first I have to dimension of LHS. LHS, that is S. S dimension is equal to, S is the distance, that is equal to m to the power 0, L to the power 1, t to the power 0. That is the dimension of S. That is the dimension of distance. So now we will switch over to RHS. RHS, that is equal to u t plus half at t square. Now we have to use the dimensions, that is velocity, initial velocity m0, L to the power 1, t to the power minus 1. That is dimension of velocity. Then dimension of time is t, I have to use plus half a t square. A is the acceleration due to gravity, whose dimension is L, t to the power minus 2. And t square, that is t to the power 2. Then by using the exponent rule, this becomes minus 1 plus 1, which is cancel out. Then overall dimension is m0, L to the power 1, t to the power 0. Then this is equal to half, which is equal to L, t minus 2 plus 2, that becomes t to the power 0, which is 1. Therefore this becomes m to the power 0, L to the power 1, t to the power 0. If we will add half and 1, the dimension of the quantity remains same. Therefore RHS becomes is equal to, that is m0, L to the power 1, t to the power 0. Therefore the dimension of LHS and RHS are equal. In dimensional analysis, the dimension of a one subject 5 kg mass is same as the 10 kg mass. So therefore this constant half and 1 3/2 does not play any role in the dimensional analysis method. Next we will switch over to another applications to check the correctness equation stated and to establish the relations between the different physical quantity. First I will be explain the questions, that is which is given in the expressions or in the questions. That means let us find an expression for the time period t of a simple pendulum. The time period of simple pendulum depends on mass of the bob, length of the pendulum and acceleration due to gravity. Now we will switch over to another applications, that is to derive an expressions or establish a relations in physics. Let us find an expression for the time period of simple pendulum. The time period of the simple pendulum t may depend on the mass of the pendulum or the bob or length of the pendulum and the acceleration due to gravity. That relations we are going to be derived by dimension analysis method. So according to this question, time period of a simple pendulum, that means what is the simple pendulum? I will first draw a diagram. This is a simple pendulum which is hanged from a rigid support by means of a thread by a metallic bob. That is called simple pendulum. It will oscillate in this manner and we will calculate the time period of this simple pendulum. This is the actually simple pendulum. In this case, the time period of the simple pendulum t depends on mass of the pendulum. Therefore, t is directly proportional to mass. And next is depends on the length of the pendulums. That is t is proportional to L, length of the pendulum, that is length of the thread. And next time period is directly proportional to acceleration due to gravity. Therefore, if we combine these three terms, the time period is directly proportional to mass, length and gravity, acceleration due to gravity. Then we will be use some indices to find its value or expression. Therefore, this expression T is equal to K, which is a proportionality constant, whose value is going to be determined by experiment or experimental value. That is m to the power A, L to the power B, and G to the power C. ABC are the indices whose value we are going to be determined by using dimension analysis or the principle of homogeneity. First, I have to write the dimension of the time period. Time period dimension is m0, L to the power 0, T to the power 1. That is proportionality constant, and dimension of mass is m, that is m to the power A, and this is the length of the simple pendulum whose dimension is L to the power B, and acceleration due to gravity dimension is L t to the power minus 2, that is L to the power C, t to the power minus 2c. That is the acceleration due to gravity. Then by adding the power of the same base, that is m to the power A, L to the power B plus C, and t to the power minus 2c. And by equating these indices of both sides, that is LHS and RHS, we find that m to the power 0, m to the power n, then A is equal to 0. A is equal to 0. L to the power B plus C, L to the power 0. Therefore, B plus C is equal to 0. Next, third one, T to the power minus 2C. That is minus 2C is equal to 1. C is equal to minus half. Then putting the value in these expressions, putting the value of ABC, and if C is equal to 0, then evaluate the B. So B minus half is equal to 0, then B is equal to half. Then ABC value is determined, A is equal to 0, C is equal to half minus half, B is equal to half. These three values will evaluate by equating the indices of both sides. Then by putting its value, putting in value in the expression, we will obtain that is T is equal to K m to the power 0, m to the power 0, and L to the power B, that is L to the power half, and C to the power minus half, that is G to the power minus half. Therefore, m to the power 0 is 1. Anything to the power 0 already, my dear student, you know, anything to the power 0 is 1. So, therefore, this expression becomes K L to the power half. Its indices is minus half. Then we will convert to positive indices by t to the power half. Half means it is the square root of this whole term. Therefore, this is equal to K L by G to the power half. To the power half, which is equal to K root over L by G. And experimentally found its value of K is equal to 6 pi. Sorry, experimental value is 2 pi. Experimental value of K is 2 pi. Therefore, T is equal to 2 pi root over L by G. Therefore, T is equal to 2 pi root over L by G. This is the expressions. So now my derivation is completed. Then we will switch over to another topic or another, that is key point. You have to remember what I explained today. That is principle of homogeneity. That is dimensional analysis to use the checking the correctness of equation and relation between the quantity and derive the relation of different quantity and conversion from one unit to another unit. So important question, what are the application of dimensional analysis? You refer the manual as well as my teaching. Next is how do you ensure that relation of physical quantity be correct? You refer, that means by applying the principle of homogeneity, whether that is LHS or RHS, that you will refer. Question that check whether the equation dimension correct, you refer, already I have stated you. And questions to establish that is the relation between physical quantity and the dimensions